Good afternoon, everyone. My name is Travis Spencer. I'm the founder of Curity. I'm joined by Jakob Ideskog, also founder of Curity and CTO as well. We're going to be talking in this webinar about privacy-enabled credentials. We're going to have a conversation that we'd like to invite you into. So please feel free to use the Q&A as we banter about ourselves. Between ourselves, you can jump in there with your questions and thoughts and comments. To get started, I just wanted to show you the agenda here on the next slide of what we're going to be discussing today, which is to just do a quick level set reminder of what decentralized identity is. It will be pretty quick because we're going to get into a lot of details later on, but we also want to talk about the wallet and what credentials are in general. And then we want to talk about selective disclosure and in particular STJOTs, and then leave you with a bit about privacy principles that we should be following in our use of credentials. That's what we're going to go through today. Any comments from you, Jakob, before we go into the spiel here?
No, it's a pretty packed agenda actually, and we're gonna go deep today. So
And you got a
yeah,
demo for us also, right?
we got a demo, small
Okay,
one.
small one, but that's great. So
Yeah,
what is the problem we're trying to solve here?
yeah, exactly. For those of you who've been here at these webinars before, you've seen this, but it's good to recap a little bit what the problem with identity on the internet today is, and it's about privacy, really. How can I tell you something about me without oversharing? And how can you be sure it's true? Like, and today, as we'll see, there are solutions for this, but they're not perfect because we can't handle privacy in a good way. In the real world, we have solutions for this. Maybe they're disappearing a bit as we're moving to more digital solutions, even physically. But I have my driver's license, and that has very good properties around it when I use it, and so on. But we'll get to that a little bit more. And another issue that we want to address and want to be able to solve is for different parties out there to not be able to correlate and collude around you, like your information. If one knows one thing and the other, they shouldn't be able to put those together and get a bigger picture and a more detailed picture of you as a user. And that's hard to solve today as it is.
And to just understand that a little bit, it's helpful to begin by looking at a real world picture of how identity works. I mean, like Jako's mentioning with the driver's license, we have government authorities and different kinds of authorities that will issue some sort of identity or credential to a user, and that user will put them in their wallet or keep them in different places in filing cabinets. And then when they need to, they'll go and present those credentials or those proofs of their identity to some other party that trusts that issuer. So like a bank trusts a government, and they'll present their social security card or their driver's license, and the bank will verify that. So that's how identity works in the real world. And the way that we've been doing identity online till now, more or less, is to take this federated approach where the end user who has an identity and wants to prove their identity will go to some sort of application like an online bank or something, and that relying party will rely on someone else, something else to assert their identity. And so the user will be ushered over to that authority like a government or something, where they'll prove their identity with a credential, and then some sort of security token will be issued to that bank or that relying party that can be verified using a PKI or some other technique. And that's how identity is done today. And
Yeah, and there's a direct line between those two. That's very important. The bank in this case has a direct connection to the government application in this case.
exactly, and a trust relationship in that direct physical communication line. And like Jakob mentioned, there's several drawbacks to that. Single point of failure, the IDP ends up being this primary attack vector, relying party collusion, and then also those risks increase if the IDP is cloud-based. So
Mm.
in a decentralized approach, the issuer is almost more like in real life, will issue a credential and the user will hang on to that in a digital wallet. And then when the user wants to go and use some sort of website or different kind of place where they want to use their identity, a verifier will collect that credential and learn who they are. So almost more like in the real world here.
Yeah.
And so there's also different kinds of wallets. We've mentioned this before in the past where we have self-contained wallets where the application itself is entirely holding on to that user identity. So if you lose it, it's gone. We joked before, Jakob, about that hard drive of the Bitcoins that got lost. You know, it was gone. So I heard in the news 2 weeks ago that the guy is actually suing the town there in the UK for $647 million because that's what his Bitcoins are worth. So if you lose your wallet, if you lose your
Yeah.
hard drive with your Bitcoins on it, they're gone. That's the self-contained approach. Whereas with the roaming approach, you have like a key escrow where, you know, maybe they're on the cloud and they can rebootstrap the wallet with those identities. And then embedded is kind of a hybrid of those.
Right. And web wallets, for instance, they're always roaming. Essentially, I've seen some interesting techniques of doing it differently, but I'm bound to some physical key or something like that. But essentially, I mean, most web wallets will be roaming in one sense or the other. But what about embedded wallets? What do you mean by that, Travis?
Well, I mean, like if you have an online banking application, maybe it wants wallet-like features, so you'll embed those wallet capabilities into that online bank, or maybe a gambling application, or maybe your airline's loyalty application will have some wallet capabilities so that you could get a credential into there proving that you're a loyal customer or you're a banking customer, or able to gamble or whatever. So
Yeah.
embedded application is this hybrid where it has other kind of functionality as well as wallet functionality.
Yeah, and that's it's pretty important because it's very easy. Most of us by now, at least in the tech space, have used wallets. I mean, we have the big ones, the Apple Wallet and the Google Wallet, and it's very easy to think like that's how you do it. But there's nothing saying that it needs to be like that. You could come up with really cool and useful use cases for your organization that only makes sense to you, and there's no real point in using a third party wallet for that. It's just your own. So you might as well just issue the credentials to your application. Maybe you use them in your store or in your organization, or maybe you present them physically, like with NFC blipping the thing that you're having the credential for. There's all kinds of use cases where it makes sense to think about, a wallet isn't necessarily its own application. It can definitely be built into something else, and that in many cases could even make more sense than it's the standalone. So it's a pretty open space. I mean, there's a lot of room for cool ideas in this area because the tech is getting there and can be used for that.
So a lot more we could say about all of that, but what we want to talk about is verifiable credentials. If that was too quick, jot in your questions or check Jakob and my previous recorded webinars where we discuss those topics at a little slower pace. But now let's get into verifiable credentials and what those are. So obviously well, maybe not obviously, but essentially what they are is claims about a subject. And they're issued to a particular user, a subject, and there's various formats and schemes. So a verifiable credential is a token. A lot more we could say
Yeah.
about that, Jakob. What is a verifiable credential?
Yeah, a token is the best word, right? It's a way to encapsulate data about the user, but the thing about a verifiable credential is how you pass it around, which we saw in the earlier slides. And that's all tokens are like that. Access tokens, they have their scheme for how you pass them around and how you use them. And ID tokens have their scheme. Verifiable credentials in the OpenID, we haven't mentioned that, but here's an example of one. It's this one is a WC3 schemed credential. So it looks like a lot of stuff, and it is. I've highlighted the interesting parts here. I mean, the type says it's a university degree credential. So in WC3, that then governs what's inside the other green part, which is the credential subject, the actual attributes or claims about the user, like degree type, degree, school, family name, and so on. There's a subject up there, and the subject, interestingly, is not necessarily the user. It's not the user in this case. It's a did, which is a we talked about this before. We're not going to go into it now, but it's really a reference to a key that the wallet has. So this credential is bound to that wallet, which is part of the protocol. So this is the credential, but oh yeah, whoops.
Jakob, I cut out there on my internet connection on the previous slide, but I wanted to say, because credentials are just security tokens, maybe you could just tell a little bit about how we've implemented security tokens in the Curity identity server, because I think that opens up all sorts of different use cases beyond just the ones that we'll maybe get into or that are more mainstream.
Oh, with the SDJOT, you mean, or tokens
Or
in
just
general?
that credentials are tokens, so they're essentially just token issued
Right,
in the
right.
blockchain.
That's a good point. In the Curity identity server, we treat tokens alike. They have a purpose in our server, which means that's how you're supposed to use them in your protocol, but they're all issued using the same mechanism, token issuers, and the VC, the verifiable credential tokens, they're also issued using token issuers. So there's nothing really preventing you from using this for other things as well, if you think it's a nice format. The access token, for instance, I mean, there's no format that is necessarily should always be used. I mean, JOT is popular, but doesn't mean that it's the best fit always. So in Curity, you can tweak that any way you want. Yeah, I don't know if it was you or me who cut out here, but
it goes to your point about creativity. So, learn about these things and see what you can do, and then use those tools in your toolbox. So, W3C credentials are one kind, but we also want to talk about another kind here. So
yeah, because before we do that, just to sum this slide up, I think the whole problem now is that when you send this token, that's what you send. It's the whole token. So there's no way with this one to say, I just want to send my degree type. You can't, because that would be a very useful anonymous information, because you don't see the subject, you don't see anything else. The subject is a key. So you would see here that whoever owned this actually has a bachelor degree. That's useful, but you can't. And that's the problem.
Right.
And that's what brings us into selective disclosures. Selected, if we take that credential we just had now in a picture rather than in a lot of JSON, it could have claims like this. We have name, birth date, email, phone number, and so on, whatever. And if we come to a situation where we only want to present birth date, we couldn't do that with the previous format that we described. Pretty much any token we've used so far within OAuth and OpenID, it can't do this.
No, so you need a new token.
Whoops, this slide looks weird. Yeah, the
So
animations were off here.
Instead of getting a new token that only has birthday in there, what we want to do is selectively disclose only birthday. But how do we do that? Because the JOT has the signature over it, so we can't alter the JOT, right?
Right, that's the problem. So we need to have a new way or a new token format that has this ability inside, and that's that we could just redact or remove the parts we don't want to send, so that birth date is the only claim that is part of this thing. So before we dive into that, we are going to show you real quick a small demo on how this works. We have three sites. We have a verifier, I have a wallet, and I have an issuer. The issuer is pink and the verifier is purple. The issuer can issue credentials to me, to my wallet, and the verifier can be used later to verify these credentials. So they're decoupled, they don't belong together. You may have seen this application before. You can try it on your own. Just go to issuer.decentralized-identity.io, and verifier, same thing, and wallet, same thing. You can play around with this. You'll find links on our website as well. So if I want to get a credential, I sign in here with some user. So I authenticated probably more deeply than I just did. And it says you have two credentials you can download. And in my case, I want the university degree credential. So I'm going to click download this credential. And there's a code here. I'm not going to use a mobile wallet. I'm just going to use a demo wallet that's online. So it says, took me over to the wallet now. And in the wallet, it says, provide the code, because if this is different devices, you also want to make sure you're actually doing this solicited and not unsolicited. So I get this. Here's my new credential. I'll call it something in my wallet.
We talked about different kinds of wallets. This would be an example of a roaming wallet, right, Jakob?
It would be exactly a web wallet. The demo itself is not roaming, but yeah. So now I have two credentials. I have a car insurance and a diploma here. So if I want to use this, I'm going to go to verifier app. And in this case, it's, apply for a job, which makes sense then to provide a proof of your degree. So it's going to ask me, please, scan with your wallet, or in my case, open the wallet. And it knows that it's asking for a degree of a diploma because there is a contract between the verifier and the wallet in that request saying, I'm looking for this type of credential and it needs to contain these things. So now we can see what selective disclosure is. The verifier said, I need the degree type, the degree school, your name, and so on. That's mandatory. I can't unselect these, but these two are actually possible to decide if I want to disclose these or not. So I can say, yeah, I don't want to show you my grade because you're not asking for it. I can show you my year, accept and continue. And then we go back to the verifier here, and we can see now that, okay, they receive the credential. They can see the type of it's a bachelor degree, was the school here, but the grade is not available. So it didn't send the grade. And the year is available because I chose to include the year. So this is pretty interesting. This is not possible to do with the types of credentials we've been using so far, because then you would have to have multiple sets of those with the information, different information in each, so you could pitch which one do I want to send, and obviously that won't fly so well. So how does this work?
Just before you jump into the inner workings of that, Jakob, was that a roaming wallet, a hybrid wallet, or embedded wallet?
That was supposedly a roaming wallet. In this demo case, it's not actually roaming, but since it was a web wallet, it would make sense to roam, because otherwise the credential would just be local. But the demo itself is actually a self-contained wallet, which doesn't make sense in the real world. It makes sense in a demo. So if I delete my web cache, it's gone.
That's great to see the different kinds of wallets and an example of that. And it's also great to see those that we can now decide which of those claims to release to the verifier. So how do these things work?
Yeah.
At least when we use the SD-JOT specification, because there's different kinds, right?
Yeah, exactly. And just to give you a background of this, so the concept of selective disclosure is not new. It's been around for a while. And it comes from an earlier concept of zero knowledge proofs, which is a bit more advanced, where we can say, how do I prove something about me without actually telling you the thing I want to prove? How do I prove that I'm above 18, but I don't want to give you my age? But all I have is my age. It's a really tricky thing. But selective disclosure is kind of like that, but it's like, how do I selectively tell you what you need to know? And some implementations are out there already, of course. AnonCreds is a big one. BBS Plus is pretty popular. But most of them are tied to a particular blockchain or ledger technology and so on. Some are not. But then there's this new one that we're going to talk about today called the SD-JOT, Selective Disclosure JOT. And it is gaining a lot of popularity. It's not yet finalized in its specification, but it's pretty far gone. And it is also the one that seems likely to be used in the ADAS2 project in EU, the European wallet for identities. So that's why it's an important one. So with a regular JOT, we have a header, a payload, and a signature. That's the structure. Anyone who's seen a JOT knows this. And an SD-JOT is essentially a JOT with extra stuff attached in the end. And so after the signature, you see these tildes. And this is what's called disclosures, and we'll get into these. So there are many, I've color-coded them so you can see where one starts and the other ends. So there are many disclosures attached in the end to this one. And then it ends with a tilde, meaning now there are no more disclosures. You could also add what's called a key binding jot to this. We thought that was a bit of overcourse today because there's going to be a lot. So we're not going to discuss the key binding jot, but essentially it's a POP or similar to DPOP, proof of possession type token that you can attach as well. Because credentials aren't always sent over HTTP. It could be sent over Bluetooth or something else. So you can't really rely on things like DPOP or MutualTLS because they're HTTP protocols. So there's a specific way to do that here. But that's all we're going to say about that, I think. Do reach out if you want to know more about that. So we have the header, payload signature, and a bunch of disclosures and the key binding jot. Since we end with a tilde, we know there is no key binding jot. If there is one, it will not end with a tilde. That's how you tell. So here's an example. If we have to the left a regular payload of a JWT, it has all the claims in there that you would expect in the way you would expect them. If we have the corresponding SDJOT, we can see that most of the claims are not visible. In fact, these many claims have been redacted or removed, I should probably say, from the JOT itself. The JOT part of an SDJOT is called an issuer signed JOT, but it's really, the thing you would think of as the regular token. But instead, they've been replaced with all of these hashes everywhere. And this element, this claim _SD is a reserved key or claim name in SDJOTs. It means these are selective disclosures that can be inserted in this level of the JWT payload, or the JSON structure, I should say, probably. We'll get to how. But you can also, yeah, go ahead.
Is it thinking of it like almost like a macro? Like I've got SD and I got this hash here, which says to the receiver, here you can insert stuff.
Yeah, pretty much. Okay. Directives like that almost. Mm-hmm. So they are referencing disclosures and saying you can put them here. So you can do that for full claims. We'll show you that. But you can also do it for the array. We had the nationalities array. It's still there. You can still see there are nationalities in this token. So I can know that just by seeing this, but I don't know any of how many they are or how many they are I see here. We'll get to that too. But instead of the actual values, you see small JSON objects here. And the objects have the key ... So that's not actually an abbreviation. That's what it should say, ... And then the hash of the disclosure. So this looks really obscure the first time you see it. It's a bit tricky. But right now, we can't tell much. If we're not careful when issuing this, we could tell a few things. We could tell that there are 2 nationalities and this number of extra claims in there. Maybe that's information that could be useful. So if we're talking about privacy, which this whole webinar is about, that in itself could be a problem. Like we could inadvertently tell the reader of this that it's a multinational here that we're looking at, even if we don't disclose any of the nationalities. So Travis, are there ways to go around that with the SDJOT?
Yeah, definitely. So there's this thing called decoy hashes. So if you don't want to reveal that or give that away, you could add hashes in there that correspond to non-values or inapplicable values. And so the hashes will be there, but they'll never be disclosed. And because of that, maybe if there's 3 or 4 or 5 nationalities, you'll always think they're multinationals, and you'll then kind of throw the receiver off of the trail.
Yeah, exactly. So you can add hashes here essentially that don't mean anything. That's what the decoys are, and that can be quite useful, especially in an array situation like that.
And here also you reveal the subject. So there's nothing saying that the subject can't be redacted. That's just an example and something as an issuer you want to think about, because that could give the verifiers a way to correlate that. So that might even be something you want to redact, but just for this example, you chose not to.
Yeah, so you could actually redact almost anything in the payload. That's an important key. But then, of course, if you redact too much, it might become useless if the holder forgets to send those disclosures when they send the JOT. But yeah. Moving on, these disclosures, how do they work? We saw the hashes in the actual payload of the issuer signed JOT, the first part of the SD JOT. These hashes are actually JSON arrays with 3 things. And this is for claims. So if I want to disclose a claim, say given name, John, if I want to make that selectively disclosable, I create this array with first a random salt. This needs to be true random. And then you have a given name and the value. And the value can be an object. It could be anything. So this could be quite a large disclosure if you wanted to. What you do then is you base64 URL encode that, and then you get a string. And you simply attach that to the end. So by just base64 encoding this thing and putting it in the end of the JOT, you have created the first part of your SD JOT. So it's not encrypted or anything when you have it here. It's just encoded for good transport. But that itself is, yeah, sorry, go ahead.
And that's that special base64 URL encoding that removes padding and stuff like that. But it's
right.
It's plain text, and that's because it needs to be viewed in plain text because it corresponds to those hashes, which we'll explain in a little bit.
Exactly.
But
it's good. There's a lot of details on the encoding actually in that spec. But
yeah, a lot actually. The entropy though is added not for the verifier, but just so that every time it hashes to a different value, right? Because there's a lot of people named John. And
yeah,
we want a verifier to be able to see, oh, my name's John. This hash corresponds to my own hash, so I know this person's name is John.
yeah.
So it's just made so that every one of these hashes that we saw on the previous slide end up being unique per John.
Exactly. So with the disclosure here, we get to the second part, which is what you're talking about, the hashing. So if we take that base64 URL encoded string and we run a SHA-256 digest over that, we get the hash.
Right.
And the hash is what we put inside the JOT. That's what we saw in the beginning. So we didn't see the disclosure, we see a sort of a reference to it, which means when you read this and you take the disclosure and you hash it and you see that it's here, then you know, okay, I should decode this, put this on this level to reconstruct the JSON payload.
And that
it's a few steps here. Sorry.
And the algorithm that you're using, you're told using that SD algorithm claim at the bottom of that JSON object, right? So that could be something else as well.
Yes, that could be something else. I think by default it should be SHA-256. I'm not sure you even have to include SD-alg.
No, exactly. I think it is default and mandatory to implement. So yeah, but everyone supports that. So
yeah, exactly. So you did 2 things. First, you base64 encoded it, to tuck on the end of the JOT, and the other thing you did was you hashed that base64 string and put that inside the JOT. So now that's how you bind them together and tell also the receiver where this is. So that was for claims. That was both the claim name and the value. So we don't disclose even that there is a given name claim. We'd say nothing. That's the key. But for arrays, it's almost the same, but it's a tuple, not a triplet. So you put the salt and the value of the array element that you want to hide. You base64 encode that the same way, and you hash it the same way. You attach the disclosure to the end, and the hash you put here in that little object that you replace the value with in your array. So ... and then the hash. So then you have to go and look at the disclosures, which ones matches this hash. So you have to do a lot of hashing actually on the disclosures and see, oh, it's this one, open it up, put it in, and then you can reconstruct the array. So you could send one of the nationalities, not 2.
And if you wanted to to make that entire nationality's object selectively disclosable, you'd use the algorithm on the previous slide.
Yeah, exactly.
And then the important thing also to remember is the JSON there that Jakob showing with those hashes in it, that's signed by the issuer. So those hashes, they can't float away there because the receiver will know, like, hey, wait a sec, that signature is not valid.
Right. So the order of process here is that you create your disclosures, you create the hash of those, you add those to your JOT, then you sign the JOT, then you add all of these disclosures to the end. That's how you have to do it in that order when you create an SD JOT. So you can't create this JOT first. You have to first create all the disclosures, their hashes, put them in the right place. So it's more complicated to work with for sure than a regular JOT. So here we can see that array element being attached to the end here of the SD JOT. And there's more actually. You could nest these things. We've talked about top level things, top level elements, that the _SD was here, and you should put everything in the root of the JSON object, but you could nest it. So you could say address is there, but I want to select it to disclose, just each one of the address claims. But then there's an _SD array in the address claim now instead. So that tells us these 4 disclosures should be under address, not under the root. But then maybe you don't want to do it like that. You don't want to say there's an address, but you also want to selectively disclose each part. Now, I mean, we're getting really deep here, but you could actually nest recursively this disclosiveness. And so you could have a top level reference saying there's an element that should be here, which is in this case the address element. But the address element itself doesn't contain any real values. It contains another just object with the SD array in there and new disclosures or new hashes that points to disclosures. So in this case, one code points to locality, street address, region, and country, but you may only send 1 or 2 of those. So you could nest, you could recurse, you could put them, so pretty much full power on what parts of a JSON document essentially that you want to be able to disclose or have as optional elements when you present one.
In this SD JOT format, in contrast to the one we looked at before, the W3C format, where nothing was selectively disclosable. So maybe it's a little bit more work for the issuer and for the verifier, but it protects the personally identifiable information of the subject, the user, more.
Yeah, it's more work. And
this work.
Exactly. And when you use these, we talked about how do you issue these now, how do you construct one? So you attach all the disclosures to the end, and then the wallet receives that full thing with all the disclosures in there. And then it's time to present, like I did in the demo, where I say I only want to attach year, not grade. How do you do that? Well, in this example, if we want to attach just given name, we remove all the other disclosures from the end because this JOT is still valid. It just, most of the hashes don't resolve to anything. They're not there. So when I send this, the one who receives that will get a lot of hashes, but only one that actually matches something. And that's the given name in this case. Exactly. So it's very easy to use for the wallet. Just drop the ones and send it because they're plain text too. So there's just basics for decode and you know what the ones are. So the wallet's job is quite simple in that case.
It's pretty smart once you kind of see it and the light bulb goes off. It's like the JOT is immutable, but the things you send these extra things beside it and make sure that they correspond. A reference of them, a hash of them is inside of that signed document.
Exactly. Yeah. Yeah, it's quite nice. And one important thing though, these are not JOTs. I mean, despite the name SD JOT, these are not JOTs. They consist of a JOT or 2 if there's a key binding in there. So you can't use your regular JOT library. If you get one of these, it's not going to understand it. It looks like a regular JOT, but the signature is all off because it has these extra things in there. So you're going to have a library that understands SD JOTs if you want to work with these.
Which is nice that if someone accidentally sends you an SD jot, you fail securely, because when you split that and you start to use that green part as the signature, every signature is going to be invalid. But
Mm,
yeah, you're gonna have to write some code or get a library to process those disclosures.
yeah. But, given all of this, if you do have that library, like we said in the beginning, these are just tokens.
Right.
The SDJOT itself is, I mean, it's designed for verifiable credentials, but it's not really a credential just by itself. It's how you use it, who gets it, who presents it. That's when it becomes a credential. So if you think this is a super duper format to use for access tokens, go for it. I mean, it works. There's nothing in there preventing you to do that, and I wouldn't say it's wrong either. In Curity, you could even configure that if you want to issue access tokens as SDJOTs. It's a bit hidden, so you'd have to ask us, but it works, and it's pretty interesting. I can think of a few cases where it could make sense, but I don't know. We haven't tried it so much yet. But it's a token, so give it a thought. What you could make out of it. So that was a lot, but you mentioned a detail about the spec, Travis, that was like one word or one sentence
Yeah.
that completely blew up when we were reading this and trying to understand. You want to tell some more about that?
Yeah, for sure. So, I mean, what we want to make sure and do, according to the SD jot specification, is make sure that there's consent, like explicit consent, and that the user has choices about that, and that they're informed, and that we're only collecting the PII that we have a legitimate need for, and that we specify that, and only collecting what's required and minimizing the processing of that data and the amount of people and services and things that are involved in processing that. And we only use and retain and disclose that PII to the extent that we need to, and that we make sure that that PII is high quality and that it's accurate, and we give the user a chance to update that if they want to, and we're open about what we're doing with the PII and transparent about that, and give notice of any changes of our terms of service and how we're processing the PII, so that individual participation and access is also achieved, and that we're accountable, and keeping information, PII information, safe, so that if there is a breach, we're giving notice, we're reporting that, but going through proper processes and procedures to keep that safe, which is audited. So it's a lot that you have to do to comply with that specification, but I think regardless of whether or not we're doing SD jots or something else, these are things we want to be doing in our handling of users' PII.
Yeah. Yeah, because when you think about it like that, and I think the reason they put that in there is also to highlight that privacy is not solved by using SDJOTs.
Right, exactly.
And there's a lot of aspects that you need to think about, and this list makes that pretty clear. Like if you're anyway issuing, super duper sensitive information to systems that don't need it, there's no privacy anyway.
At least not as
And
much privacy as you want. So you got to be thinking about these things as different perspectives, right?
yeah, and there are, I mean, we have these three parties. We have the issuer of credentials, we have the verifier who receives them, and we have the wallet too. And sometimes it's the same organization doing all these three things. It's an embedded wallet and so on. So maybe that it's not that big of an issue. But very often, and in the ADAS project, for instance, these will be distinct organizations. There will be one issuing, there will be one doing wallets, or one many, and another doing verification. And all of them need to think about privacy for this to work. If we start with the issuer, for instance, I mean, we could think of a lot of things that make sense to consider here, right? Take the nationalities array that we just discussed.
Mm-hmm.
By making that into an array like that, it tells you numbers, how many are there, unless you add those decoys.
Mm-hmm.
Should you really make it an array? Is there a different way you should be presenting that information so you don't inadvertently disclose sensitive data? Like how do you construct that token? I think makes sense for an issuer to consider. How much should be in a token, or anything you want to
Yeah,
add on that?
exactly. Just because, like, suppose a user is over 18, and then you might, as an issuer, add other claims in there, like register to vote. It might be true or false, able to carry a concealed weapon, true or false. But if they're under 18, maybe you don't put those things in. So just by having those extra claims in there, even if they're redacted, you, as a verifier, will be able to know if the user is over 18. So their privacy will be infringed. And that's entirely up to the issuer to be thinking about.
Yeah, because the and this is also different from the other credentials. The SD JOT does not really have a schema.
Mm.
It's a way, like it's a regular JOT in that sense of a JSON payload and whatnot. Whereas the WC3 model, there you kind of define like there's a university degree credential. Where in the SD JOT, it's not really the same. There's probably things around that will solve that issue anyway, but not in the token itself. And that means that that type of flexibility you're talking about, as an issuer, you could be using that a lot and not thinking about the implication of that from a privacy perspective. That just by having extra disclosures, you told them something.
And I mean, one thing the wallet designer definitely needs to think about is that they have all of those disclosures. And the fact that they're disclosable means they're sensitive. So those are things you want to keep very, very safe as a wallet designer. And as a
Yeah,
user, it's also something to think about, do I want a roaming wallet or do I want a fully contained wallet on a mobile device? It's kind of that balance of, if I lose my device, I might lose all of my credentials, but still it gives me that extra sense of safety. So as a wallet
yeah,
designer, you might want to be providing both of those, right?
yeah. And also just the UI. If I, as a wallet designer, by default just enables all credentials to be sent, or no credentials, no disclosures to be sent. That's a huge difference, because the user won't know and understand these things. It will most likely assume that if the wallet tells me to send this, it's probably because I need to, because otherwise I'm going to have to do it again, because the issuer, the verifier is going to ask again, those type of things. But the wallet knows what the verifier needs, because that's in the contract of the request. So it should help the user to provide as little as possible, and probably inform the user that you don't really have to send this. This is optional if you click some. So that type of thing is probably worth thinking about as well when you're designing wallets for privacy sensitive systems.
And then the verifier should definitely be thinking about not asking for more information than it needs, right? So in your demo, almost all of those claims were required and only a couple were optional. So
Yeah.
minimize the amount that you need and reduce it to just what is necessary, and then also make as many of those optional as you can.
Yeah, because if you as a verifier don't do that, the wallet will have to comply, and will have to check all of the ones as mandatory, and there's no point in having selective disclosure JOTs at all, because we're just oversharing information anyway, and over requesting. And also, when you get all of that information, it's your responsibility then to keep that, retain that to the right period, all of that. So it comes with regulations on your end, on you, on what to do with that information that you requested. So if you request as little as possible, you have less to worry about in that end. So there's a lot to think about, because it's not the tech that will save privacy on the internet. It's how we use it and how we build it, and moving together forward with this.
Yeah. If you have any questions, now would be a great time to jot them into the Q&A tool. But this was a
Thank
really
you.
good discussion. Jakob, like you said, a lot more to say.
Yeah, maybe we'll come back and talk about key bindings and other details. There's a lot to be said in general around verifiable credentials. But if you want to try these things out, they're available in the Curity identity server already. You can issue and verify and work with the wallet for SD JOTs and for regular credentials as well. think of use cases for this for your organization, because the train is moving really fast. I mean, this is coming. It will shift not only EIDs, but I think general onboarding of new users, how we deal with certificates of various kinds and so on. There will be a lot of things happening in the coming years now. So if you haven't started to experiment with this already, I really encourage you to do that and get a feel for it and how this will fit into your organization.
So we do have one question here that just came in about whether or not SDJOTs are a replacement for opaque tokens. I'd like to hear your perspective on that, Jakob, but I would say no, because the SDJOT has the issuer JOT together with the disclosure. So the client application sees all of those. They just base 64 URL decode them and has it all. Whereas with an opaque token, it learns nothing about the subject of that token.
No, exactly. I think what in Curity we have something called wrapper tokens, which is an opaque token, but it's a JOT. So you can know a few things like where can I use this JOT, or who issued it, and how long is it valid for, but nothing about the user or the claims itself. Those are still, you have to go and resolve it with the server. So it's both an opaque and a JOT at the same time. Super useful if you're in a sort of multi-cloud scenario, or you need to know things about the token. Maybe it could be replacing that in certain scenarios, because you could use the issuer signed JOT and send that across, and then push the disclosures to the gateway preemptively with the hash of the signed JOT or something like that, and store it there. So be a variant of, I think you said the split token earlier, Travis, or phantom token or something like that.
I think in many ways, I like this for split token better, because if you split there on the signature on the period, and then you send that and all of the disclosures to the gateway, it will have that. And then what actually the body, the payload part of it that goes out and is used as that opaque access token will be even more opaque. It will have nothing in it. So I think I haven't whiteboarded that or seen or tested that, but I think that might be something also.
That could work. I mean, a few drawbacks at this point is probably the library support for SDJOTs. It's harder for the applications later on to receive these, more work to reconstruct the actual data, work, all the hashing and those things. So there's some drawbacks like that. The other thing is you can do a lot, but you can't do everything. You can't selectively disclose part of a string. And the scope, for instance, is a string of all the scope values in there. And if you just want to, say, well, I want to send parts of the scope when I call that system, and other parts of the scope when I call that system, you can't do that with an SDJOT. You'd have to use some other mechanism then to describe permissions and access, which obviously you could. You could translate that into something else. But yeah, it's an interesting thought. We'll see where we land on that.
Yes. If there are any more questions, we'll answer those. Otherwise, we'll leave it there for now.
Yeah. So thanks, Travis.
Thank you, Jakob.
Fun as always.
Talk to you again.
Yeah. Have a good one.
Until next time. Bye for now.
Bye.